Testing. Hello. Testing. Cool. Okay. So today we will be covering. Today we will be covering the. Oh, goodness sake. Okay. Today we'll be covering chapter 3.2, which is the derivative of log functions and exponential functions. Okay. So again, it's going to be business as usual. I throw some definitions, we work some stuff out. It's going to be great. All right. So I'm going to call it a definition. The definition of the exponent rule is going to be as follows. Let A be some real positive number, then, not then, if f of x is equal to a to the x, then f prime of x is going to be written as 1 then f prime of x is going to be written as a to the x times ln of a. Right. Easy enough. All you have to do is figure out what your a value is, and then just boop, pop it in. Okay. Again, you can always write this as ln of like 5 or whatever, like if a is equal to 5, right? You don't have to simplify it. Okay. But now let me ask you this, right? Let's say f of x is equal to 3 to the x squared, right? What you're going to notice is that you technically have an inside and an outside function. The outside function is going to be 3 to the x, and the inside function is going to be x squared. Do you see how it's composed? Okay. And so if you wanted to derive f of x, right, you would have f prime of x is going to equal, actually, let me rephrase all that. Okay. In particular, you can actually classify this as like the g of x, right? And the h of x, which means f of x is equal to g of x composed with h of x, like that, right? Pop this into here, structure pops into there, right? But that means you know that f prime of x, because it's a chain rule, is going to be g prime normal h of x times h prime of x, right? But if g is 3 to the x, right, then that means you get g prime of x is equal to, as we stated here, 3 to the x times ln of 3, right? And that means you have h prime of x is equal to 2x, right? And that means you can put it all together and say this is equal to 3 to the h of x, right? Times ln of 3, right? Because you're substituting h of x into x, right? And then you're going to multiply it by h prime, and h prime is going to be 2x right? Okay. But wait, we know what h of x is. We know that h of x is going to equal 3, or sorry, h of x is going to be x squared, right? Like that. And then this is just kind of business as usual, right? Which if you really want, you can rewrite as 2 ln 3x times 3 to the x squared, right? That means you can also have a more generalized form, right? So the expo rule with a chain rule built in is going to look like this. It's going to look like the derivative of a to some g of x, right, is going to be a to the g of x times ln of a times g prime of x. Okay? And that's the built-in chain. Okay. For me personally, I have a hard time using g's and f's. So I'm going to call this my way of remembering. It's going to be the derivative of some a to some u, right? Where we identify u is some function of x. If you notice, I don't write this as d dx. That's because I assume the only variable I'm working with is x. Okay. If you prefer writing d dx to be clear, it's fine by me. Just be mindful for when we're deriving in terms of other variables. Okay. And a is some positive real number, right? And that's going to give you a to the power of u, I'll write that in pink, times ln of a times whatever the derivative of u is. Okay. Or as I like to call it, Aolanadu. Okay. Aolanadu. The worse your southern accent is, the better, in my humble opinion. Okay. And I'm going to throw another rule at you. I'm going to call this the log rule. Okay. The basic form, like earlier we had the basic and a more general form. The basic form is going to be if f of x is equal to log base a of x, right? Then f prime of x is going to equal 1 over x ln of a. Easy enough, right? But that means that the more general form with a chain rule built in is going to be f prime of x, or sorry, if f of x is equal to log base a of g of x, like that, right? Then f prime of x is going to equal 1 over, well, the inside, leave the outside alone, right? So 1 over g of x ln a times g prime of x. And that's your built-in chain. Okay. Again, feel free to color code it. I personally like to. Here's how I remember it. I'll say f of x is equal to log base a of some function u. I really like using functions called u. I don't really know why. It just is. Then f prime of x. Also, I notice a lot of you guys try to take a derivative and you don't write the prime. You just tell me that the derivative is equal to the original function. That's just not necessarily true. Okay? Is equal to 1 over u log base, sorry, not log base, ln a times the derivative of u. I think I switched the colors between this and the exponents, but it's okay. All right. That's it. The rest of this is going to be me running some examples. So if you feel pretty good, cool. If you don't feel good, keep watching. Please do work these problems out though. They're in my notes. Okay. So let's do some. Actually, that's not true. There's something. There's a point. There's a point to this. Okay. So some examples. So let's say h of x is equal to 3 to the x, right? Then h prime of x should be, well, a to the u, right? A to the u times ln of a times the derivative of u, which is 1. Okay. If it helps, color code. I'm going to say a is equal to 3, u is equal to x. Then obviously ln of a is going to be ln 3. And the derivative of u is obviously going to be 1. Right? Another example would be, let's say h of x is equal to 6 to the power of x squared plus 5x plus 1, right? Again, a is going to equal 6. U, or you can also call it g of x, it's fine too, is going to be x squared plus 5x plus 1. ln of a is going to be ln 6. Sometimes you'll also see it written as du like that, that's fine too, is going to be 2x plus 5, which means you have h prime of x is going to be a to the u plus 5x plus 1 times ln a times du. This is wrong. Don't ever do that. Put your parentheses in. We pay rent out here. Okay? And then of course you could like shuffle the order around a little bit. Like it's multiplication. It's fine. All right. And now what if I give you something a little more interesting? What if I give you h of x is equal to e to the x? Right? In the same way, a is going to equal e. ln of a is going to be ln e, which should be interesting to you because this should equal 1, right? And then, oh, if you don't know why this is true, please review your algebra. I will test you on this. You have u is equal to x, du is equal to 1. And then that means you have, oops, h prime of x is equal to a to the u. So a to the u times 1 because ln of e is 1 times 1 ln e du, which interestingly enough gives you e to the x, right? And I'm going to give you one more interesting example. So as a personal, I guess, way of thinking, I would prefer to give you guys a more general form than a more specific form, um, because it's more versatile. Okay. And this will explain why in a second. Let's say h of x is equal to e to the x cubed plus 7x plus pi, right? And you know that a is equal to e, ln a is equal to ln e, which is equal to 1, right? U, oops, is equal to x cubed plus 7x plus pi. Put in parentheses if you have a tendency of losing your work. And du is equal to 3x squared plus 7, right? And that means you have h prime. I'm going to stop writing x just because it's a lot of work. It's going to be a to the u, so e to the x cubed plus 7x plus pi times 1 times 3x squared plus 7, right, in parentheses. Okay, so if you have that, right, what if I give you h of x is equal to e to the f of x, right? Or let's make it fun. Let's call it e to the u, right? Some function. A is equal to e, ln a is equal to 1, right? Actually, that's a terrible idea. I'm not going to call it that because I've been calling everything in their mom u. Let's call it f of x. So let's say you have ln x is equal to e to the some function f of x, right? No, let's try that again. Let's say your function h of x is equal to e to the f of x, right? Then your a value is going to be e, ln a is going to be 1, your u is going to be f of x, and your du is going to be f prime of x, whatever that is, right? Which means h prime is going to be a to the u. So it's going to be e to the f of x times, oops, 1 times f prime of x, right? Which you can also write as e to the f of x times f prime of x. All of that is to say, right, if you have base e, you know ln a is going to be 1, so you just have to do all that, okay? Easy money, right? Let's do some log examples. So let's say 1 h of x is equal to log base 2 of x cubed, right? You know that a is going to equal 2, ln a is ln 2, right? This is how we're getting it. Okay, log base a. Again, you can call this g of x. I'm going to call it u. I'm used to saying log base a of u. If you use f of x or g of or yeah, if you use g of x, it's fine. Okay. So let me make sure I didn't lie to you guys and it's consistent. Okay. So let's say my u or g of x, it's the same thing, is equal to x cubed. Then du or g prime, same thing, is equal to 3x squared, right? And that means we have, actually, let me write it over here. h prime is equal to 1 over u, or g of x, so that's going to be x cubed, times ln a, which is ln 2, times x du, which is going to be 3x squared, right? Which you can also write as 3x squared over x cubed ln 2, which you can also write as 3 over x ln 2. I'll also accept this. That's also fine. Okay. Easy money, right? What about if I give you h of x is equal to log base 7 of 3x squared plus 8x, right? Again, your a is going to equal 7. I won't color code this. Your u is going to be 3x squared plus 8x. ln a is going to be ln 7. du is going to be 6x plus 8. Put that bad boy in parentheses. And that means h prime of x is going to be 1 over u, which is in parentheses 3x squared plus 8x. Did I put this guy in parentheses? Okay. Times ln a, which is ln 7, times du, which is 6x plus 8 in parentheses, which you can also write as 6x plus 8 all over ln 7, 3x squared plus 8x. Okay. Again, let's say I have log base e of x is equal to like h of x, right? Then again, a is equal to e, ln a is 1, u is x, du is 1, and that gives you 1 over u ln a, which is 1, times du, which is 1, which gives h prime x is equal to 1 over x. If we do that, what if I give you f of x is equal, oh, sorry, g of x. Nope. H of x is equal to ln of g of x. Well, what this is secretly telling us is this is log base e, right? So you know a is equal to e, ln a is equal to 1. Okay. You know your u is going to be g of x. You know your du is going to be g prime of x, which means when you put it all together, you have h prime of x is equal to 1 over u is g of x, times ln a, which is 1, times g prime of x, and that gives you 1 over g of x times g prime of x. Built-in chain rule, specifically for log base e, or ln, which is what I will primarily be giving you. Okay. I think these are all very fun functions. I hope you guys enjoyed it. I definitely do. Yeah. Thank you for your attention. See you guys next time.